So before we start with the actual talk, I'm going to share a small story. You know, in martial arts, when newcomers learn a lot of moves, they display all their techniques and they spend a lot of energy trying to impress people. And that's how young people do. But when they get older and maybe they come close to what some people would say masters, they actually display a lot of calmness and not using that much energy, just putting the right move at the right moment. And that makes them as effective as a youngster, but just in a wiser and more economical way. And that may be the spirit of that talk, how to use C++ in a wise way, using only the feature we need, not trying to impress people with a great display of all the tricks and the new things, but just knowing what is the impact of every line we write and how to use just the thing we want in C++. Okay, so I'm a Red Hat employee, I'm Serge, and I love doing a lot of things, tinkering, which is basically what we will be showing in this talk, but also woodworking or martial artist or whatever. And to begin the talk with a joke, you probably know that one, but C++ is exactly that. You increment C, but you return the old value. And that's exactly the spirit of that talk. We'll get the old value of C, but with a few bells and whistles and not that much. But it will still be C++, and we can choose. So yeah, let's get free of all what we know. Let's get rid of runtime type information, exceptions, and maybe even try to disable the standard library runtime, so not linking with the standard library, and maybe removing some headers and see the consequence of it. And once we let free of all these things, we still have an interesting C++, and that's what we're going to see. So RTTI, you can tell your compiler, so I will be using only Clang or GCC flags during this talk. So you can disable runtime type information with -f, no RTTI. And when you do so, you remove some dynamic behavior of C++. So two parts of the language can no longer be used. When you do so, you can't use dynamic cast anymore. Well, actually, you can in any place where a static cast would be enough. But if you really want the dynamic behavior of dynamic cast, it's no longer possible with no RTTI. And likewise, you can no longer use type ID. There is a small, the compiler will still generate some type information that are needed for exceptions, but the actual type ID keywords can't be used anymore. And you can still do a lot of things without RTTI, and there are plenty of reasons why you would want to remove them. Most of the time, it's for the code size, but also for the overhead of how dynamic cast is implemented. And some very important projects we're going to see a bit later in the talk are actually removing RTTI. So yeah, if you don't need it, remove it. That's totally in the C++ mood. But there is one aspect in the standard library where you actually need something that's actually provided by RTTI is when implementing std_any. You need some way to bind a type to a type erased identifier. And type ID is a great way to do that. But if you don't have type ID, then maybe you still want std_any. And if one have a look to the implementation of std_any from the libc++ LVM version, libcxx, then there is this small structure, unique type info, which is actually just a class parameterized by a type with a static int associated to that class. And due to the way it behaves, this int will have a different address for every different type. And so the get fallback type ID function just takes the address of that particular static variable and use that as a unique ID. And that's how libcxx makes itself compatible with the no RTTI flag, which actually means that this lib can be used with or without lib RTTI, and it works fine in both ways, which is great. And maybe if you have a header-only library, you want to follow that path. You can also remove exceptions, especially when you come from C. Exceptions are a bit surprising because they don't follow the usual control flow. And so if you value C because of the principle of it's easy to understand and it does only what I see, then exceptions don't match that pattern. So maybe you want to remove them and use an alternate error reporting strategy. Maybe not the global error variable from C, but just returning the error value or things similar. And to do that, -f, no exceptions, and then you won't be able to throw or to catch any exception within your code. It will still register each function unwinder, which means that if you're compiling a code with -f, no exception, but it's calling a code that actually raises an exception, then the exception will faillessly go through the stack and not being stopped by the fact that your actual code does not support exception. It will just forward the exception upward, and that's the library unwinder that does it. It has nothing to do with actual C++. But always when writing header-only library, you may have customers or users that compile their code with exception, and some other people that don't compile their code with exception. And you want your header library to be compatible with both. So unfortunately, you need to rely on some macro processing to do that. And the thing you see the most is detect whatever compiler-specific macro is defined when you actually have exceptions. And when you do so, you define a specific macro function that raise or throws the actual exception. Otherwise, you have a fallback strategy. Here, it's aborting, which is probably not what you want to do, but actually, that's a possible way of handling exception. You can also long jump, set jump if you want. Well, there are different strategies there. But just saying, you can have a header-only library that is compatible with both exception on and exception off, and you can have a fallback behavior. Next, and so these two parts were pretty common, and a lot of projects use them. Now we are diving into a less usual thing, which make it more interesting at least. So maybe you want to remove the standard library runtime. So I'm not speaking about removing the standard library as a whole. So you can still use some headers, but what you don't want is link your final program with the standard library. One reason for doing that could be make your code easier to distribute because you don't have version issues depending on the library runtime, or maybe you want your code to be smaller, or maybe you want to implement your version of some of the standard library runtime. Well, whatever the reason, it's possible to do so. And the only thing you need to do is during the linking step, don't link with using your C++ compiler as a driver, but instead use the your C compiler as a linker driver. Because by default, if you use G++ or Clang++ as a linker, it will add the right lib std_c++ flags to the linker. And if you're using C, it will only link with the C library by default. So that's a decent way to avoid linking with the STL. But when doing so, you're removing some stuff, obviously. Even if the standard template library is mostly header only, there are a few things that still require some runtime support. So for instance, many symbols come from the IO stream header. So you can't use stdc out if you don't link with the standard library. More interestingly, maybe, even though the std string class is a template class, it's explicitly instantiated for std string. And so the compiler accepts the symbols to be defined somewhere, and even though it has the whole class definition in a header. So that's where we have explicit instantiation, and in that case, it may depend on the vendor of your standard library. Someone may decide to explicitly instantiate, I don't know, std array of int for 3 integers, and in that case, well, you need to provide this symbol somewhere, and not only the header definition. Maybe more interestingly, if you don't try to override them, you don't have access to new and delete anymore. Because by default, there is a global operator new and a global delete operator. And these two are also defined in the standard library as explicit symbols. So you need to overload them if you want to actually be able to use new and delete. But if you're only using placement new, that's fine. Placement new does not require any runtime support. You also have issues with in-function static constructors. That is because the standard mandates that static variable to be thread safe during initialization. Basically, we all know that static variable within function are only initialized at the first call of the function. And if you have 2 threads that initialize them almost at the same time, the language guarantees that it will only be initialized once. And to do that, there is a word, a mutex, and that specific symbol is defined, at least for libcxx and libstdc++, within the standard library in the runtime. So if you don't have them, if you don't have that library, you can't use thread-safe static constructors. There is a flag. I think it's no thread-safe static or something like that, where you can disable the thread safety of this constructor. And in that case, you don't require the symbol. But you're explicitly telling the compiler that you know what you're doing. Interestingly, global variable with non-trivial default constructor also require runtime support because they need to be registered to be initialized before accessing to main. And there is a specific function in the standard library runtime to do that. And if you don't have the runtime, you can't have this kind of globals. And that's almost it. So surprisingly, getting rid of the standard library runtime is not that much of a pain, and you can still do a lot of things, mainly thanks to the standard library being header only, or header mostly. If you still want to use the operator new, you can obviously provide your own implementation, and so if you're in the C word, you can just rely on malloc and free and forward the call to these two. You will need to overload the array version of these two, but otherwise, this is a decent alternative to using the system one. Depending on whether you want exception support, you need to implement it. Of course, combine this with the previous slide, but it gives you a rough idea, and you can also have your pair type new and delete operators. That's obviously fine too. And then we go to something that I've honestly never used before, but it exists. It's in the standards, and that's for the real people, the people that want to remove all the things. That's called freestanding. So when using the standard library, you can either be in freestanding mode or in non-freestanding mode. And most of the time, you're not in the freestanding mode. But if you want to, that's basically you only have access to a few headers. And those headers, most of the time, only contain type definition or limits, this kind of thing. So that's the bare necessary to write interesting C++ code, I would say. It also enables exception and type info, but you can disable them with no RTTI and no exceptions. And maybe surprisingly to some people, if you're in the right language standard version, you still have access to coroutines. Even though coroutines do require some heavy compiler support, but they are part of freestanding. So this is mostly useful for people doing hardware stuff. And I don't expect it to be useful for most software programmers, but it's nice to know that the standard already defines this kind of small footprint C++. And you can, so it's very limited in what you can do. For instance, you know the notable absence of of array, of tuple, or this kind of very useful header-only tools. It turns out that there is discussion right now in the committee to be able to pick some parts of the freestanding stuff to specify, okay, I want to be freestanding with tuple or with some parts of the headers and not only these few ones. And it's also very similar. You have this -m kernel flag that tells you disable RTTI, disable exception. It's not freestanding, but it's keep it as minimal as possible. And there may be alternative to freestanding, a workaround, but really that means you re-implement all the thing you want from scratch if you want to be conforming to freestanding. So I don't think that's the way to go. Use freestanding only if you really need to. So we've been talking about removing stuff, but and that's not super great. I mean, you not define yourself by the thing you don't do, but by the thing you actually do. So if you come from C and you remove all the things we've seen before, you still get a lot of pretty cool tooling. And I would love coding in C with that, because coding in C with constexpr and the ability to have the guarantee of something being compiled in my code and not only relying on the compiler to maybe optimize them is super cool. You still have access to templates and all the thing you can do with that, which is also a great part of C++ that do not require library support. You can write your type easier with auto, and you still get your range-based loop. You can still have all the class parts of C++, encapsulation, inheritance, even diamond inheritance. It does not require any library support, so feel free to use that abomination. It's still in without the need for anything else, and you also get stronger typing as how you get your reinterpret cast and static cast and const cast that you don't have in C. So instead of saying, oh yeah, if I come from C++, only having access to these few items, well, it's a bit dispiriting. Take it the other way. If you come from C, or if you want to convince someone who's a C fanboy to use C++, say, okay, you can still use C++ without being frightened, and you get access to all this, just pass a few compiler flags, and that would be enough. And now let's jump to the second part of the talk, where I take a few projects And some of them are very famous. Actually, I think all of them are. And they all use a C++ dialect. And let's see what they tell us about it. So GCC, famous compiler, it's been written in C for a long time. And there are good reasons for that. Because when you're the standard compiler for the whole Linux ecosystem, and it has been the case for a long time, it's important to be bootstrappable. And to do that, being written in C++ basically adds an extra step in the bootstrap chain. But still, GCC now has a lot of pieces in C++, which are described in this link that you may click further. And the first statement of this coding convention is C++ is complex. And we want it to be not surprising. And I find that super interesting, because one thing that C advocates state all the time, and I tend to agree, is I like C because it's not that surprising. At least compared to C++, C is not super surprising. And so they have specific ruling about things to avoid or to use very carefully or to use in a very non-surprising way. Automatic conversion must be explicit. So you know when you're typing one object to another. Overloads of operator or of function must be not surprising. A function with a given name, all the overloads must be doing something very close to the original name and not having totally different behavior. If you're using operator plus, you have some semantics that you probably need to follow. And if you're using operator minus, that's the same. Try to keep overloading non-surprising. Default argument is just a special case of overloading, plus they want all default value to be pod types, so that you don't get surprising cost when you're using it. They disallow IOStream mostly because they need they already have a great Unicode support, and due to the heritage of C, they have a lot of printf-based routine and they are still using it. And most non-surprisingly, no RTTI, no exceptions, both for, they already have their own error handling strategy and they don't want the code size increase. Yeah, and that all makes sense. You may see, oh, these old people from GCC. No. Just think the other way. They come from C and they embrace the part of C++ they want to use, and they recognize the advantage of C++ in that area, and that's great. LLVM. So the LLVM community is somehow a bit different from the GCC community. The LLVM code base is using C++ 14 as the default language, but so there are less constraint on which part of the language you can't or can use, but they still disallow a few specific constructs. No static constructors to avoid the initialization fiasco. No generalized initialization syntax when using actual constructor, just because the conversion rules are a bit messy, and so it's better to be explicit there. They warn about usage of auto, especially about implicit copies that may occur there. And so they prefer auto reference or auto star instead of just using auto. And of course, or maybe not of course, but it turns out that they are not using RTTI and not using exception. Actually, LLVM has its own RTTI system based on registering type and such, which is much more lightweight and based on the fact that they control the whole type environment, so they can register them by hand. But they don't have any exception specific stuff, just using regular return value error or this kind of thing to support error. And as a last point, Numpy. So Numpy is a scientific library for Python, written mostly in C and providing array facilities for the Python ecosystem. And it's written in C. It's written in C, but there is a lot of of generic thing within Numpy. Basically, when you have the addition of two arrays, whatever the type of the elements, you have the same addition, and that would be a perfect case for a template code. But Numpy is written in C, so they have their own preprocessor that looks a lot like a template system from the web world. And I managed to convince them that instead of this homegrown language, they could use just the part of C++ that they needed. That is, only use template plus C. And with only that, you have exactly the language they actually use, but it's supported by editors, it's supported by a compiler, it means less code to maintain, easier to read, all these kind of good things. And so I submitted a first pull request that got merged a few months ago, where I'm translating their custom language from C plus specific macro to raw C++. And then as compiler flags, we are disabling RTTI, we are disabling exception, we are not linking with the standard library. So in the end, the code is very close to the code they were writing in C, but it's easier to read, and the editor has nice highlighting and all this kind of thing. And it also opens possibility to use from Numpy library written in C++ with C++ only headers. So a lot of things can be done thanks to that change. And it's a very nice and unusual use of C++. I'm very happy they agreed to move that way. So that's a lot of guidelines, but to enforce them, you can write text, but it assumes that people read text, which is not always the case. Fortunately, you've got tooling, and this kind you can use clunktid and define your own set of rules and make sure your code obeys this rule by running this linter or checker or whatever name you want to tell him. And it already exists for LLVM and for the most famous CPP core guidelines. You pass your clunktid-based tool on your code base, and it makes sure it follows the rule you've been using. Or stated otherwise, you've got your specific warning for your specific homegrown subset of C++, and you can encode the behavior of this subset within clunktid. And so it can be part of your pull request, checking on whatever. And yeah, that's cool. Define your own language embedded in C++ and make clunktid check it. Some concluding words. So what I like with C++ is whatever page I open in the handbook, I learn something new. And that's great as a case study, but that's probably not as great as an engineer. So it's fine to use C++ as a Protean language, and you just pick the feature you want and just disable or check that the other parts are not used. So to do so, of course, you must be aware that there are dependencies between features, like as I stated, when you enable exception, you still get some kind of RTTI, but that's fine. And then you document, write tools to enforce your choice, and yeah, you have your new language, and that's great. And that's also the end of my talk. I only have 1 minute left, so unless I get a question in the chat, we can end it here.